Good morning all of you. Welcome to Rajdhani Engineering College. My name is Professor Kumares Rao, Associate Professor in Department of EEE. Today I am going to do another beautiful experiment in FEEE lab. FEEE means Fundamentals of Electrical and Electronics Engineering Laboratory. Okay. So today we'll do a very beautiful experiment in FEEE lab. So as you know that FEEE stands for what? Fundamentals of Electrical and Electronics Engineering Laboratory. So the aim of the experiment is to draw the VI characteristics curve for a Zener diode. Okay. So now let us switch over to the main circuit diagram and also the symbolic diagram of Zener diode. Okay. So as you can see here, this is the circuit symbol of a Zener diode. So what is Zener diode? Zener diode is a heavily doped PN junction diode that works only in reverse bias conditions, and they are special semiconductor devices that allow the current to flow in both forward and backward directions. Now for the Zener diode, the voltage drop across the diode is always constant irrespective of the applied voltage. Also, Zener diodes can be used as a voltage regulator. Now, if I talk about the circuit diagram of Zener diode experiment, so this is the circuit diagram of the Zener diode experiment. So I have connected the P terminal to the negative terminal of the battery, supply variable battery, and N terminal to the positive supply of the battery. Now, in between, I have to also connected ammeter over here and a voltmeter across it. Okay, so this is the basic typical diagram, circuit diagram of a Zener diode experiment. Okay, so now you can see this is the trainer kit of a Zener diode experiment. So also we can call as Zener diode characteristic apparatus. So as you can see here this is a voltmeter attached, here a ammeter attached. You can use this ammeter in milliampere mode or microampere mode, and here is a toggle switch. You can set it at 15 milliampere or 150 microampere, different input and output ports, one voltage regulator or controller, and you can see here there are 3 Zener diodes and their respective Zener breakdown voltages. 5.1 volt is the Zener breakdown voltage for this Zener diode. 8.2 volt is the Zener breakdown voltage of this diode. Okay, so respectively you can choose any one among these 3 Zener diodes. Okay, now it is on off switch. Okay, now we'll do the connection as per the circuit diagram I have drawn. Okay, now let's start to the connection. So first connect the, first as you can see here, first let us connect the P type to negative terminal of the battery. So here suppose this is the P type, I have got to connect the negative terminal of the battery. Okay, next I have to connect the N type to negative terminal of the ammeter. This is suppose we are choosing this Zener diode. So connect the N terminal to the what? Negative terminal of the ammeter. Next connect the what? Positive terminal of the ammeter to the what? Portion of the battery. So here let's connect the plus terminal to the plus terminal of the battery. Now next also I have to connect the voltmeter across it. Okay, so here is the voltmeter, so I have to connect the voltmeter here, plus to plus, and then also minus to minus. It is the minus to minus. So now circuit diagram is purely complete as connection is purely complete as per the circuit diagram. Okay, now just set to 15 milliampere. If I setting to 15 milliampere, let's zoom it. If I setting it to 15 milliampere, I have to take the reading from the upper scale reading. If I setting the 150 microampere, I have to take the reading from the down scale reading. Okay. Now we'll on the power supply. Now see that this is the power supply on off condition. I have to make the on. Okay. Before that, I have to also first put the supply on over here. Okay. Now see that here I have to vary until I get a deflection in the ammeter reading. Now since I have chosen this J2 Zener diode, so its breakdown voltage is 8.2 volt. That means before any voltage variation, before 8.2 volt, I cannot get any deflection in the current. So when I will acquire at this 8.2 volt, there must be a deflection in the current. Now see that. So just take that. You have to take different readings of the voltage and obtain its different corresponding readings in the ammeter section. Now see that, carefully observe that when I am reaching to 8.2 volt, okay, there is a deflection in the current. Okay, that means 8.2 volt is the Zener breakdown voltage of this diode. Got it? So in this way I will take multiple readings of voltmeter and multiple readings of current, okay, and I will draw a VI characteristic curve among these readings. So as you can see that I have taken multiple readings of voltage and multiple readings of current. This is the voltage across Zener, or it is VZ. This is the Zener current or IZ. I have taken here 12 readings, obtain your 12 readings of voltage as well as current. Now I will use these readings to draw a graph. That graph is called VI characteristic graph. Okay. So finally you can see here I have obtained a graph that is across your VI characteristic curve for Zener diode in reverse bias. You can see that this is the graph I have obtained from the readings I have taken out of 12 number of readings. Okay. Now our experiment is purely complete. Thanking you all.